Breaking news! The scientific revolution just took off from 1543 to 1687. Hi, this is Julia Shea broadcasting from, guess what, her house! Today we are going to talk about the 5 important events that happened in the scientific revolution. Wait a minute! But first, how did the scientific revolution start?
The Renaissance led to the scientific revolution because the Renaissance invented the printing press to spread new ideas and to solve problems in navigation and astronomy. That caused a shift in accepting ancient authorities to relying on experiment, mathematics. And now it's time for the future. Come on, guys! Introducing the Copernicus heliocentric theory. The Copernicus heliocentric theory started in 1543. Made by Nicholas Copernicus. It is an astronomical model that proposed that the sun is stationary in the center of the universe, and the Earth rotates on its axis daily and revolves around the sun once every year.
A few moments later.
And now, moving on to the next event. Now we're talking about the geocentric theory. The geocentric theory began with a Greek astronomer, Claudius Ptolemy, in the 2nd century. Wow, that's a long time ago. It is an astronomical framework with the Earth being centered in the universe. Surrounded by orbiting planets, stars, and the sun. And Ptolemy used a system called epicycles, where planets moved on small circles and also moved around the Earth on larger circles. We know what that means. But years later, the geocentric theory was proved to be wrong. After I just read all this, come on, guys. And the heliocentric was right about the sun being centered in the middle of the universe.
And now we're talking about the Galilei telescope's observations. Did a lot of things. Yes, they did. The Galileo used the self-built telescope, this thing right here, telescope to re-see astronomy, and he did it surprisingly. First of all, that surprised me. He built a telescope, guys. Come on. And found the 4 largest moons of Jupiter that are called Io, Europa, Ganymede, and Callisto. What are their names? And he found the faces of Venus, mountains/craters on the moon. The moon, guys. Talking about the moon with this telescope. Moon. Sun drops using this telescope to look. And the Milky Way that made of stars. He found the Milky Way that is made of stars. Guys, come on, I said that twice, so we should know that by now. And that helped people see what the universe looks like. We just saw so many things. And he found this telescope right here. And now we are jumping on to the next event. Wait a minute, guys, Now we're jumping on to the next event.
Boom! Now we're talking about Kepler's laws, baby. Let's go, Kepler's laws. So, get these things away after I just do that. We are talking about Kepler's laws. Kepler's laws of planetary. Planetary. Kepler's laws was made by Johannes Kepler. Wow, his last name's Kepler. That makes sense. Between 1609 and 1619, guys. Whew! There are 3 laws of Kepler's. The first law is the eclipse means all the planets move around. This is a perfect example. Here's Earth, here's the sun. It's moving around. Wow! It's not really that hard to understand, guys. Kepler's law. The first law, eclipse means all planets move elliptical orbits with the sun located at one of the 2 foci of the eclipse. Again, not that hard to understand. And yeah. One moment. I got this. Eclipse laws. This changed the understanding of planetary paths from perfect circles into eclipse, which allows the distance between the planet and the sun to be different throughout its orbit. This thing, remember, not that hard to understand. Earth, arrow, sun, circle. That's the universe. Boom! And now, get this out of here. And now, the second law of equal areas means a line segment connecting a planet to the sun. Example, Earth to this. Bring back our telescope as a line. Boom, connected. Lines look at the planet. The connecting a planet to the sun sweeps out equal areas. Imagine, long area, big area, long area. It's equal area. We should know this by now, guys. We learned this in math class. Come on. During equal intervals of time, this means a planet's speed varies based on the distance from the sun. Remember, guys. The sun. periods means the square, not the rectangle, doesn't matter. The square of a planet orbit's period is directly proportional to the cube of the semi-major axis of its orbit. This connects the orbital time to be different planets to their average distance from the sun. The sun, guys. Come on, can't forget that image. And now it's time for the final and last event. Let's go. Newton's laws. In motion, there are 3 laws made by Sir Isaac Newton in 1687. The first law is inertia. Inertia is an object that stays at rest or moves at a constant velocity unless acted on by a external force. For example, if we don't touch him, he's not going to move. But if we push him, he's going to move. That is an unbalanced force. The second law is a force/acceleration. The acceleration of an object is directly proportional to its mass. F equals ma. If you don't know what that means force equals mass times acceleration. And like this, if she pushes it, it's acceleration, it moves forward. And not least but last, Newton's third action and reaction. So for every action, there is an equal or opposite reaction.
Thanks to Hamilton, our cabinet's fractured into factions.
So, example, I jump, the floor pushes up, I push down. Opposite and equal reaction.
Try not to crack under the stress. We're breaking down like fractions.
Do we have any questions before we end this podcast tonight? Yes, you right there in the luscious pink hair.
Okay, thank you. Wasn't it worth fighting for the scientific revolution?
Yes, it was worth fighting for the scientific revolution because it gave people science, reason, logic, and astronomy to have in this world. Any more questions from tonight's broadcast? Yes, you right there in the pink shirt.
How does the conflict lead to the change?
The conflicts lead to the change because it changed people's version of the world. It gave people a explanation on why something is happening and observation and what is going on with astronomy.
Bye!
Podcast. Thank you for watching this broadcast tonight. See you next time.